So the first exercise I want to demonstrate is breaking down a formula into a tree. So consider this relatively complicated formula. So P and Q implies not P implies not Q, or P implies not R. First thing we need to check is what is the main connective of this formula. And you can see that the main connective of this formula is the arrow right here. The arrow right here connects whatever comes on the left-hand side of the arrow to whatever comes on the right-hand side of the arrow. So we can break this down into two, and we have P and Q on one side, and then not, P implies not Q, or P implies not R. Breaking down the formula on the left-hand side is pretty easy. We can see that the conjunction is the main connective, and so we split it into P and Q, and there is nothing much we need to do on the right-hand side. Now, for the formula on the left-hand side, we need to realize that the main connective is not the disjunction right here, but it's the negation. And you can see that if you just look at the parentheses. So this parenthesis right here opens here and closes all the way till the end. So that means that the negation applies to the entirety of the formula. So in order to break it down, we just need to remove the negation. So we have P implies not Q, or P implies not R. And then here we can see immediately that the main connective is the disjunction. So we can break this down into P implies not Q on one side, and then P implies not R on the other side. And then we need to break it down this for the formula. That's pretty easy. We can see that the main connective is the arrow, the implication. So we have P on one side and then not Q on the other side. And similarly here we have P on one side and then not R on the other side. And the not Q can be further broken down into Q, same with the R. And then we're done. So we can see that all the formulas that we have are atomic formulas. All the formulas at the bottom of our tree are atomic formulas. And so once we check that, we are done.